In this video, I'll show you how you can use some of the basic properties of sine and cosine to simplify expressions. These skills will be very valuable when we get into more complicated things like solving trig equations and establishing trig identities. In the first example, we'll use the even-odd properties for sine and cosine. So recall from class that cosine is an even function, while sine and tangent are both odd functions. We're asked to simplify sine of 45 degrees plus sine of 315 degrees divided by cosine of negative 45 degrees. So the first thing I'll recognize is that 315 degrees is almost all the way around the circle. In fact, it's 45 degrees shy. That means sine of 315 degrees is equivalent to sine of negative 45 degrees. So I'll make that substitution. Now I can employ my even and odd properties. Sine being an odd function, I can pull that negative out. Cosine being an even function, I can ignore that negative in the denominator. That leaves me with sine of 45 degrees minus sine of 45 degrees divided by cosine of 45 degrees, which just gives me 0 divided by cosine of 45 degrees, which is just 0. Let's look at another one. In this next example, I'll show you how you can use the cofunction identity to simplify an expression. You might see it in radians, or you might see it in degrees, but essentially they're the same thing. It says that sine or cosine of pi over 2 minus an angle is equal to the other function of the angle. Let's look at our example. Cosine of 20 degrees plus sine of negative 70 degrees. Well, since sine's an odd function, I'll pull that negative out. That leaves cosine of 20 minus sine of 70. I'll rewrite sine of 70 as 90 minus 20. I could have just as well rewrote cosine of 20 as 90 minus 70. And in the next step, I'll use my cofunction identity. Sine of 90 minus any angle is equal to cosine of that angle. So sine of 90 minus 20 is equal to cosine of 20. And cosine 20 minus cosine 20 is equal to 0. Let's look at another example. Our next example will use the Pythagorean identity. The most common form of the Pythagorean identity is sine squared plus cosine squared equals 1. But you also might see it solved for cosine squared or solved for sine squared. Look at the example. We're going to simplify 1 minus sine squared of pi over 4, all squared. So first thing is we'll notice that 1 minus sine squared of an angle is equal to cosine squared of the angle, for the same reason that sine squared plus cosine squared of any angle is equal to 1. So I'll substitute cosine squared of pi over 4. That leaves me with cosine squared of pi over 4 squared. Well, cosine squared squared is cosine to the 4th power. So I have cosine of pi over 4 all raised to the 4th power. Since we know that cosine of pi over 4 is root 2 over 2, this is nothing more than 4 copies of root 2 over 2 multiplied together, which makes 2. All right, let's take a little break here. Just got to check 6ABC. Think we're going to have a delay tomorrow? We're not on the list yet. Let's see. Oh, nothing yet. We'll come back to that. One more example. In this last example, we are going to use the periodic properties for sine and cosine. You'll recall that cosine of theta plus 2 pi k is equal to cosine. Same thing for sine. Tangent, tan of theta plus pi k is equal to tan. Look at our last example. We want to simplify sine of 30 plus sine of 390 plus sine of 750 plus sine of 1110. Well, you'll notice that 30 degrees and 390 degrees are 360 apart, and 750, that's 360 more than 390, and 1110, that's 360 more than 750. So this is the same thing as sine of 30 plus sine of 30 plus sine of 30 plus sine of 30 because of the periodic property, which is just 4 sine of 30, which is just 4 times a half, which is just 2. All right. And that's it for tonight. I'm just going to check Ribnik's e-board one more time and then get off to bed. What's going on here? 2-hour delay, 85%. Okay, I'll take it. I gotta close all this stuff. Good night.